Hello everyone, I am Neha Thakur. I am an Associate Solutions Architect with AWS UK. This is one of the episodes of the video series where we will be meeting amazing women in the SA role, that is the Solutions Architect role at AWS UK. Know about them, their job role, and then dive deep into a tech use case which helped AWS customers in their cloud journey. Today, we have Urmila Raju with us. She is a senior solutions architect from the enterprise segment of the UK SA team. Hi Urmila, thanks for joining us today. How are you doing?
Hi Neha, I'm doing great. Thanks for having me here today.
It's a pleasure, Urmila. Could you please tell us about your role as an SA in AWS?
Yeah, sure. I'm Urmila Raju. I'm a senior solution architect at AWS. Prior to AWS, I worked with a few of the major UK banks. I started my career in India and later moved to the UK in 2016. So at AWS, as you would know, there are various types of solution architects. There are specialist architects, partner solution architects who work in collaboration with partners. And there are field SAs or account solution architects. So I am an account SA, directly working with customers to help them with their cloud journey. So I primarily help them with tech aspects such as unblocking challenges, helping them with their migration and modernization journey, enabling the customer teams on AWS Services through hands-on labs and design workshops. That's basically my role.
Great. So could you please take us through one such tech area and a customer that you helped with?
Yeah, sure. Today, I'm going to take you through a recent scenario which I worked with one of my customers in the financial services industry. And to be honest, this is a use case which is prevalent across customers in various industries. So it's about how customers can benefit from building a modern data lake solution on AWS, align their technology to their data strategy, and how they can start seeing business value immediately.
I agree. This is a common issue that a lot of customers and organizations are facing, and it would be great to know how you have approached this problem.
Yeah. So let's start looking at the current state architecture of these customers, what their challenges were, and see how we can overcome them. So customers usually have different types of data sources, so like files, transactions, and payments. So which fed into a legacy data warehouse. And in this case, this customer had a relational database on a commercial database engine, and they had like complex store procedures and transformations within the data warehouse. And then this was visualized, the final data was visualized using third-party BI tools. Actually, these third-party BI tool which this customer used was a really good enterprise tool. But the thing is, the business users didn't make the full use of this tool. And there are a lot of analytical reports directly run on this data warehouse. And these business users, they were using legacy tools like spreadsheets to as end-user reports in this analytical platform.
So what were some of the challenges that the customer was facing with this architecture?
Yeah, definitely. Let's go through them. The key challenges with this approach primarily was the operational overhead. So this relational DB kept growing, and the maintenance effort that the team has to take was more than the actual value that they were getting out of this whole analytical platform. And next thing is customers are tied to long-term commercial licenses of this relational database engines that they were using, and they needed like frequent upgrades and renewals as well. And next thing is there is a lack of flexibility for innovation in this architecture if you look at, because data sources can be of different types and the speed of ingestion can be of different types. But that level of flexibility is not available in this architecture currently. And finally, the business users, they are not getting the right data at the right time. And their resistance towards modernization due to mainly because of the skill gaps that they had within their teams.
What are some of the steps that AWS took to approach these challenges?
Yes, so we as an AWS account team, that is the solution architect and the account manager. We sit down with the key stakeholders of the customer, understand their challenges and the business outcome that they are looking for by building a modern data lake architecture on AWS. So we always work backwards from the customer requirements. So that's what we start with. And also, we do not do a big bang approach on this. So we suggest customers to build a few use cases on AWS on this new foundational platform, and then use it as a base to migrate the rest of the use cases that they have on their legacy platform to the target.
That's a wonderful approach, Urmila. I believe you've used some mechanisms to help the customer with this journey. Could you please share that with us?
Yes, so it's basically doing the right kind of discovery with the right kind of people. So we sit down with, we bring in the tech and business specialist in analytics from AWS, and then put them in front of the customer, right? Have the right kind of discovery session, and then design workshops, and that's where we come out with an target architecture on AWS.
Okay. Can we dive deep into the architecture?
Yeah, sure. Yeah, let's do that now. So first of all, we recommend customers to build a modularized and loosely coupled architecture like this one that you see on the screen, and give them the ability to bring data from various types of data sources of varying sizes and types. So each of these sources can have different ingestion speeds based on their use case. For example, data sources can be structured and unstructured. And in terms of ingestion, it can be like real-time events, which needs a streaming ingestion and processing. Whereas there are data sources which are like a huge volume of data that you need to do like a one-off migration or continuous migration. And there can be data sources where you can benefit better by doing batching. Yeah, so these are the different types of ingestion that usually a modern data lake platform would help achieving.
Great. This is something that the customer lacks in their current architecture, right? The ability to ingest data at various speeds.
Yeah, that's exactly right. So the customers can start the value of this architecture immediately and very clearly. So irrespective of the ingestion method, the goal is to bring all of these data sources into a centralized data lake. And that's where all the raw data is going to reside to begin with. So this will act as a common data store from which all of your data analytics pipelines will be then built. And we recommend customers to decouple all of these transformations, because in the current state architecture, you saw how the transformations are all within the same data warehouse, right? So here we decouple the transformations from the raw data store, and then store the transformed data into a curated data store.
In relational database, there are table schemas for data transformation and querying. So how does that work with the data lake?
Yeah, that's a good question. So usually when customers start building their data lake, there will be like hundreds, and you can end up with hundreds and thousands of data sets in your data lake. So it's essential to build a data catalog where you can keep the metadata separated out from your data store itself. So that data catalog is going to provide you the underlying schema of all of this data set. And any transformations or jobs that you run on the data stores will use of the schema that you define in your data catalog to do this querying. And that's where I want to introduce you to the querying and analyze component of this architecture as well. So which will again use the data catalog for getting the schema and querying the data sets that is in your data lake.
That makes sense, yeah.
Yeah, and finally, the curated and the queried data will be visualized on it can be like an AWS native BI platform or a third-party tool, as in the case of this customer that we discussed. And another important point with this architecture is the ability that this architecture gives in segregating the permissions for different users. For example, the data engineers and scientists can be given the necessary permission to work on maybe the transformation job or the data querying job as required. And on the other side, the business users So in this use case, we are talking about the COO and CMO function, because those are the use cases that we will be discussing now. So those business users can be limited to just the visualization part and not accessing the underlying data sets directly. So that's the advantage that this architecture brings in.
Great. We can definitely see the agility that this modularized architecture brings to the customers. And Urmila, you mentioned earlier that this customer is a financial services customer. So I believe privacy and data governance is utmost important to them and to any other business. So how do you manage that here within this data lake?
Yeah, that's absolutely right. So that's what we are going to talk about next. So data governance and security are key for a data lake architecture or any other architecture that you build on AWS. And primarily, it's very important for FSI customers. So I have highlighted some key function here that is related to this data lake architecture, which is like granular access control, a business data catalog, and audit trails and monitoring.
That's great. We can evidently see the level of difference between the current architecture and the target architecture. I am here curious to see what AWS services that you've used to build this target architecture.
Yeah. So AWS provides like a broad and deep level of services to meet every customer requirement. And the choice of services definitely depends on the customer requirements. So as I mentioned before, we work backwards from the customer requirements. So in this example, we are going to see the services which we used with respect to this customer use case. But the choice of services can be definitely different based on the different customer requirements. So in this example, the customer had two business requirements. The first one being from the Chief Operating Officer or the COO function, where they wanted to identify the bottlenecks in their transaction settlement process using the transaction events. The second use case was from the Chief Marketing Officer, that's the CMO function. They wanted to know like what's their popular product launched on their website using the clickstreams data from the website, and also combining that with the customer relationship management data from their CRM platform.
These two business requirements look like great use cases.
Yeah, definitely, because this is the one which is going to help us in seeing how these three ingestion speeds are going to relate to. So this nicely showcases the different types of ingestion required for the data sources. So the first one being Amazon Kinesis data streams, which helps customers to receive streaming data from data sources. Also, Amazon Kinesis Firos is a delivery stream service which can process the streams like with or without transformation and feed it into your data lake.
Can customers use Amazon MSK, managed streaming for Kafka, instead of Kinesis?
Yes, of course. If customers are comfortable with the Kafka platform and they want to leverage on that knowledge, then they can definitely use Amazon MSK in place of Kinesis. But if they want to, they do not want to have the operational overhead of maintaining underlying clusters and servers, then Kinesis is a great choice because it's a serverless service.
Agreed, yeah.
Yeah. Okay, next moving on to the ingestion of the next data source, which is the database migration service, which we see for the next data source that we have here. It can connect to various relational database services and also NoSQL databases and ingest the data into the data lake. So with the DMS, so which is the database migration service, you can perform like one-time full load of your database, or you can capture like continuous data changes that you have on your databases and bring it into your data lake as a continuous migration as well. And finally, for the clickstreams data, Amazon, again, we are using Amazon Kinesis Firos in this place. So in this case, we are using it for buffering the incoming data, because that's what suits this use case and this pattern well. And it can batch, compress, and encrypt if you want. So these are the features that is available within Amazon Kinesis Firos to batch your data and then finally send it into the data lake. So which is actually going to be built on Amazon S3 here.
We are referring to S3 as a data lake here. How does it differ to a data warehouse? And you've also been using the term lake house. Could you please explain that?
Yeah, there are various terms and it can be confusing at times. AWS offering of a data lake is Amazon S3 and an offering of data warehouse is Amazon Redshift. So S3 and Redshift provides a unified natively integrated storage layer for your lakehouse architecture. So in this example, we are not extending this architecture into a data warehouse, that is to a Redshift yet. Typically, Redshift stores like highly curated, conformed, trusted data that's structured into standard dimensional schemas. So that's how Redshift data is structured. Whereas S3 provides exabyte scale of data storage for structured, semi-structured, and even unstructured data for that case. So that's the difference.
Right, understood. Thank you.
Okay, so the next we are going to the processing layer of this architecture. So where you see the ETL bit on the screen. So that can be based on the type of data that we use and the structure of the data. That can be different, and also the speed of ingestion. There are different processing tools that you can use. But in this example, we are going to use AWS Glue. So AWS Glue is a serverless pay-as-you-go ETL service that you can use to build a lot of transformations to read and write back your data into Amazon S3. So it has a lot of ETL capabilities and enables ETL pipelines without the need of managing the underlying servers or clusters.
Sorry, another question here, because I keep comparing this with the relational database. So in data lake, how does data schema changes be accommodated? Like, for example, if we want to add a new column to the CSV from a data source, how does that work?
Yeah. So this is a common question from across customers. Whenever there are new data sets added or the schema of the data changes. So as I mentioned before, we're talking about the catalog here. So we have something called the glue crawler, which actually crawls the underlying data sets that is there in your data lake and creates the schema and the metadata, and that's what gets stored into the Glue data catalog. So whenever there is a changing schema, so a new version of the schema is crawled by the Glue crawler and then it is stored into the data catalog. So that's how it works.
Makes sense.
So now we are going to the query and analyzing of the data from the data lake. So the service that we recommend to the customers to query and analyze like terabytes of data without having to load it into a database is the Amazon Athena service. So business analysts, data scientists, and engineers can run complex SQL queries for the data that is in your data lake using the schema that is defined in the Glue data catalog. And then finally, these data can be visualized in a like a BI dashboard, either using Amazon QuickSight, which is again a serverless offering to create fantastic BI dashboards, or the customers can continue to use their like existing BI tools. As in the case of this customer, the enterprise BI tool that they were previously using, they were still planning to use the same by using the data sources from S3 and Athena. So that covers the overall architecture, and I just want to cover briefly about the last bit, but not but the most important bit, which is the security and governance. The first thing being the AWS Lake Formation service. So Lake Formation provides the central catalog to store metadata for all datasets hosted in the lakehouse. So it can be either from Amazon S3 or Amazon Redshift. This can act as a central catalog for that.
So is this similar to Glue data catalog?
Yeah, mostly. So Lake Formation contains both the technical and business metadata. So from the Glue data catalog, we get the technical attributes such as versioned table schemas, the last updated timestamp, partition data, all those from the Glue data catalog. But there can also be business attributes like who is the data owner, data steward, or the sensitivity of the data in the columns. Like this column has got PII data. So those kind of information can be stored as a business data catalog in lake formation. So another key feature of lake formation is the granular level of permissions that it allows to set up on the data sets. Like you can have like row level or column level permissions for the data sets. And the users, like data scientists or engineers, these groups of users will be restricted to that level of permissions that you assign to each group or user within lake formation. So, and the last two services of this architecture, which are key services for audit trail and monitoring, or CloudTrail and CloudWatch, which really helps for not just this architecture, but for any architecture to scale and to be maintained at the required performance levels. These are key services.
That looks great, Urmila. Considering that the customer was on a legacy architecture, how did they adopt to so many new AWS services?
Yeah, that's a tough call for customers, and it's a deep learning curve as well for them to learn about all these services and get familiarized with these services and continue to operate and maintain these services in the cloud. So we have various support models to help them do this. So that's where the key role of a solution architect is. So we do technical enablement sessions for these customers to get them up to speed with these services. So the level of enablement depends on the level of skill set each customer has. So for this customer, sample customer that we are discussing, we started with some immersion days on key services that is used in this architecture. And then immersion days are nothing but a combination of presentations and hands-on labs that help them to get familiarized with these services. And then we conducted deep dive sessions on design workshops with their key stakeholders to get to this architecture. So that's how we enabled them. Yeah.
That's great. Could you please share a little bit more about how AWS helps customers with their development and deployment?
Yes. So once they are familiarized, the next stage is that, right? Like how do we help them to develop and then get the solution into production? So AWS offers a lot of support mechanisms to do that. So one such support mechanism is AWS Partners. So AWS has a wide network of partners who specialize in migration and modernization programs. So they can help them with a technical consultancy, or they can even provide tech resources to get the whole system built on AWS. So there are examples of where customers have been able to build an end-to-end data lake solution in a period of like 8 to 10 weeks, as short as that. So, but the level of the timeline, but of course the timeline depends on the level of support from the organization, the leadership support, and also their skill levels. So one thing I want to highlight here is that irrespective of the support mechanism chosen by the customer, we as solution architects act as a trusted advisor for the customers to help them throughout their journey, right? Starting from discovery until their deployment into production. We are there with the customers to help them enable, build and deploy and see their business outcomes as soon as possible.
Nice to know about the wide range support that AWS provides to its customers. So what were the key outcomes for your customer through this modernization?
Yeah. So first of all, if you go back to the key challenges that we are talking about, the first one was the operational overhead. So here the operational overhead is greatly reduced because the services that we use in this architecture are serverless or on a pay-as-you-go model. So that's where they are largely benefiting from. And also this gives the ability for the customers to move away from the commercial licensing, the long-term licensing that they are tried to when they are using the legacy data warehouse on an commercial database engine. So in this example, the key business owners, the COO and the CMO function, started to see their business value immediately, and the further revenue generating opportunities that this architecture could bring to them. It provides the flexibility for them to innovate on new use cases and also migrate the old use cases in parallel. Also, the architecture is extendable to other data types. So currently, we are seeing a data lake architecture on S3, right? But this is easily extendable to a data warehouse as well, because customers could have varying requirements of having like a dimensions and facts, a structured relational database that is needed for the analytics purpose. So in that case, this can be easily extended to a data warehouse, which is Amazon offering, being Amazon Redshift. And this is where customers start to see the value of a modularized system. So it improves the agility and the productivity of the staff that are working in this architecture. And lastly, which is not the least, that customers usually see about like 30 to 40% of cost savings by moving away from a legacy platform and building this kind of a modern data lake on AWS.
That's brilliant, Urmila. We can truly see how customers are benefiting and how AWS is helping customers with their cloud journey. And we can also see how your role as an SA greatly influences it. Thank you so much for taking out your time to join us today and take us through this customer's journey and the exciting use cases.
Yeah, thanks a lot, Neha. Thanks for having me on the show.
Thank you everyone for watching this video, and I hope you enjoyed this session. See you next time. Bye.